Welcome to COVID Sense, a series of videos that tackle the data behind a lot of what we see and hear about COVID. Today we're going to take a look at vaccines. And as we've been hearing a lot of lately, vaccines are giving great hope to a lot of people that we're going to return to a life of normalcy, and hopefully soon. So we've got someone here to help us take a look at what's behind these headlines. And Deanna, welcome. And would you like to tell us a bit about your background?
Sure. So my name's Deanna, and I'm the principal at Kaleidoscope Strategic. We're basically a medical research and education communications firm that specializes in preparing reviews and guidelines in cancer treatment. So our job is to get into the data and to package it all up, sort through it, package it up for clinicians and patients so that they can make informed decisions regarding their care. So if I can translate those skills to this particular area and package up the data so that people can make great decisions, then I'd be very pleased to be of service.
Okay, that sounds great. So headlines and all we're hearing in the media suggest that vaccines are effective.
Yeah, this is pretty exciting. In cancer, you don't ever really hear about things that are 94, 95, 90% effective, which is really exciting. And so I'm really looking forward to digging into this data. And there certainly is a need for something to help us through this pandemic. We've all been locked down for almost a year now. And, the spring is here and hope for the future. So let's take a look at this and see if it's going to help us out.
Okay, so let us know what we're going to walk through with respect to this topic.
Yeah, so I think to really fully understand this area and to make good decisions, we'll probably have to cover off 4 key areas. I think the first one is to understand how vaccines work, their efficacy, their safety, and, at least here in Ontario, there's a fairly big vaccination effort that's underway. And so is that plan sound relative to what we know about the data? I've just listed some of the claims that I looked over our Health Ontario website, Ontario under COVID-19. And these are some of the things that they say about vaccines. So whenever I read something anywhere, I don't ever just take it as fact. I want to go and check the data to see if what they're saying is actually true or can be supported by data. That's what we do. So we'll take a look at some of these claims, like the vaccines have completed the full development cycle. They're the best way to stop COVID, that they're safe, and that vaccinating the elderly, for instance, as a first course is the key way to go.
Okay, so there's a lot to cover here. So how about we get started?
Yeah, let's do that. So let's start with considering how our immune system works. We have 2 main branches of our immune system. We have innate immunity and we have adaptive immunity. Innate immunity is basically our first responders. They're the people who see the invader, the virus, identify it, and ideally clear it before viral load mounts. Then we have adaptive immunity. Adaptive immunity is basically a coordinated attempt by our body to identify invaders that have actually infiltrated it, tag them for identification, and then removal by a coordinated T-cell response. Innate immunity would be rapid first response. Good way to remember adaptive immunity is target, clear, and remember.
Okay, got it. So why the big emphasis on antibodies? We hear a lot about that.
Yeah, the focus on antibodies, although it's just one part of a coordinated immune system response or immune response, is because vaccine studies use antibodies, which can be measured within days or weeks of a vaccine, as a surrogate endpoint of fighting disease. So there's an assumption made that if you have antibodies, that you'll be able to fight disease long term. Now, because the immune system is so multifaceted, at times that's true, because if you can identify a viral invader, you can clear it. But for instance, if you have insufficient innate immunity or some problem with other parts of your immune system, that might not always be the case. So let's take a pause and just consider the effect that COVID-19 has on a bodily level, on our bodies. So that's called the pathogenesis of the virus. So we know that in young people who have healthy immune systems, there's very little effect from COVID-19. They're able to identify the virus and clear it with limited viral load. So you can kind of see that illustrated in the panel to the left of the youthful system. The initial immune response is strong and it's able to clear it. Once the invader once the virus invades our systems and is looking for in the alveoli of the lung, basically a coordinated T cell response or adaptive immune response is able to clear that out of the way. However, in a system that's compromised, for instance, an aged system, they're just not able to clear the virus fast enough, and viral load mounts. And so they're dealing with a lot more virus. They have to deal with a lot more invaders. So there's a stronger immune response required. And in addition, elderly tend to have lower T cells. And so the coordinated adaptive immune response to remove viral invaders is compromised, resulting in greater aggravation of the pro-inflammatory pathways, which result in cytokine storm, organ damage, acute respiratory failure, and even death. Other people who we know to be vulnerable are, for instance, diabetic and obese patients, or people, and they basically have higher ACE2 levels, which allow for viral infiltration, easier viral infiltration, so they're dealing with a higher viral load again, which can result in severe disease. And then people with chronic inflammation, say for instance cardiovascular disease would be a good example. They already have activated inflammatory pathways, and so when the virus comes along and binds to TLR4, it basically aggravates this thing, resulting in hyperinflammation. So again, that also can, that compromised immune response can lead to more severe disease. So basically, we've got two types of systems. We've got some people who are vulnerable to COVID-19 and can result in severe disease. And then we've got other people who are able to clear that quite well. So let's consider how our immune system responds at a cellular level. So what I've done here is I've created a storyboard which depicts or simplifies a simplified depiction of COVID-19 invading our cells. So it all begins with the virus engaging our cell, which is the blue circle. The virus is the red triangle, through the spike protein, which is the little blue triangle there. It uses that to enter into the cells. Once in the cells, it moves to our nucleus, at which point it engages the DNA to prepare mRNA, which is a little instruction packet for constructing viruses. That little mRNA packet then engages with our ribosomes, which are our protein factories, and produce tons of virus to the point of explosion, at which point that virus is launched into our system and identified by our immune response, which basically tags it using antibodies and uses a T cell coordinated response to remove the virus from our system. Once the antibody response, or once the adaptive immune response is complete, those little antibodies are stored in our immune library, T cell and B cell memory, so that next time we encounter the invader, we'll have antibodies and we'll know how to respond well.
Okay, so our bodies are able to develop a myriad of antibodies to COVID and remember how to mount a response, which is pretty impressive.
Yeah, and the great thing about our natural immune response to COVID is that we have a number of different antibodies to different parts of the virus. So no matter what part we encounter, we can more easily identify it and clear it.
Okay.
So let's consider how our immune systems respond to the vaccine and what the vaccine is. So here, the vaccine begins in a lab where they extract the mRNA, which is the instructions for building the spike protein, which is what's used to infiltrate our cells. They then inject that spike protein along with aluminum salts, which are basically immune stimulants, into our body. The mRNA is able to infiltrate our cells with a liposomal sac that they've created, so it's a way of facilitated entry. It then moves directly to the ribosomes, at which point the mRNA engages with our ribosomes to create now spike proteins specifically. The spike proteins fill our cells to the point of lysis. The spike proteins are spilled into our system, at which point our bodies identify them as foreign, mount an immune response, tag them with antibodies for the spike protein specifically, which then allow our T cells to coordinate a response and clear it from our system.
Okay, so this kind of looks like a COVID response, but it's not really, correct?
Yeah, so very similar in terms of response. The main differences are that we're developing antibodies specifically to the spike protein and not any other proteins like we would normally with an immune response. And secondly, it's not technically an infection, although I would say the definition of a virus as defined by the CDC is any tiny organism that multiplies within a cell causing disease. So here you can see that it doesn't, because of the way that it was designed, it is able to infiltrate our cells, but we need to be injected with the virus through vaccination. And then it acts probably like a pseudovirus in our systems, resulting in the development of antibodies to that specific protein.
So whenever a vaccine is in development, there's a certain level of evidence that's required. Am I right there?
Yeah, so they've put these mRNA vaccines through a development process. So let's just take a look at some of the basics of a development process. So what we're looking at here is in human trials. And in order to prove that something works, you need to compare it in humans in a phase 3 controlled trial, which is the green band up here, to show that it is better than whatever the standard of care is at this time. So our standard is our innate immune or natural immune response to COVID-19. So we need to prove that the pseudovirus or spike as we would call it, can stimulate a similar immune response and protect us against an infection. So basically we're looking to see if the vaccine can protect us from a COVID-19 infection, basically in a phase 3 controlled trial, so controlled against placebo. So a classic development process for a vaccine stretches over about 10 years. You can see that it's multifaceted. It has the light blue component, which is identifying the target and animal and lab models to see how the virus works. It then moves into phase 1 dosing and antibody titer studies, then to phase 2 safety and efficacy studies, and finally the phase 3 controlled trials where they look at efficacy and safety. So I've heard lots about the pathway not being compromised, and I would say that that's true in that the key trials, if you can see here on the bottom left, of in-human trials were actually done, in the sense that they did phase 1-2 studies, and then they followed it with phase 3 studies, but they didn't do the same extensive testing in the lab and in human trials to see how we respond. And you can see also that the development was so compressed that we really only have data on this for about 1 year. So that can't tell us anything about long-term effects at all.
Got it. So when we hear a claim like the vaccine has been thoroughly studied, is there a rational basis for that being able to be promoted?
Yeah, so I think it has fulfilled the key criteria, which are the in-human phase 1, 2, and phase 3 trials, particularly the placebo-controlled trials. However, because the development cycle was so compressed, we really don't have any long-term data on what the efficacy or the safety is long-term. So let's just wrap it up now and think about what we've learned. So claims are that the mRNA vaccines are state-of-the-art vaccines. I would say to that, yes, in the sense that they're a brand new class and they're cutting edge. It's new technology. So I think that's really exciting. Unlike other vaccines, because it's relying completely on the DNA sequence, they can be quickly developed, which is fantastic. No hosts required, such as when you're developing other vaccines. However, I would say technically it is similar to a manual infection of a pseudovirus. So it's almost like a man-made virus that's infecting our cells and producing an immune response, which is similar to the immune response that we would mount against COVID-19. In terms of development, I would say yes, they've done all the key in-human trials. By collapsing 1 and 2 trials, they managed to do antibody titers and also safety data and dosing all together. They did the placebo-controlled trials, which I think are great. However, we did skip the extensive animal testing models, which give us insight into long-term systemic effects. And we only have limited safety and efficacy data limited to 1 year. So I think that that's something that we just need to consider in our decision-making.
Thank you for watching this COVID Sense video. For more videos like this, please see our YouTube channel.